girls, I'm just going to do the last example here, which is part C, and this is on page 39 in your notes. So the question says when 0.200 grams of phosphorus, and so that's this bit here, is burnt in oxygen, so we know we're burning it in oxygen, we produce 0.456 grams of an oxide of phosphorus. So we know that we've got some compound at the end that's going to be a phosphorus oxide, and we're going to deduce the empirical formula of this oxide. So before we start, the very first thing we have to do is we need to figure out the masses of our two elements. So our two elements are P and O. So phosphorus and oxygen. We can see that we've got 0.200 grams of phosphorus, and we're going to end up with 0.456. So if we do a simple subtraction, minus 0.2, we end up with 0.256 grams of oxygen. And that's the first thing we're going to write down. So we're going to write down the mass of each. So the mass of phosphorus is this, and the mass of oxygen is that. Okay, so there are two masses. What do we need to do next? We need to go back to the mole. So we're going to divide them by their masses on the periodic table. So when we look on the periodic table, we're going to get that the mass of phosphorus is 31 and the mass of oxygen is 16. Okay, what we're going to end up with is 0.00645 to 0.016. Then we divide by smallest, which is the smallest of the two numbers, obviously this one. And we end up with a ratio of 1 to 2.46 or 2.45. Now, the ratio here is not a whole number. So it's not a whole number. So we could do a couple of tricky things, but it's quite obvious that we need to multiply them by the same factor until we get to whole numbers. So I'm going to multiply both of them by, and you can pause and have a think. What am I going to multiply this? This is very close to 2.5. So I'm going to multiply it by 2, and I'm going to end up with a ratio of 2 to 5. And so therefore, that's very close. Now, it's not an exact kind of number, and that's due with sig figs and the like. But what we have here is we've got P2O5 is going to be our empirical formula.